Hi students, we're beginning a new chapter, chapter 7. In this section here, we're going to be working with solving linear systems by graphing. So in order to solve linear systems by graphing, there are steps to follow to help you get the answer you need for this. So what you're going to be doing is you are going to be given two equations. And you need to write both equations in a form that is easy to graph. And that's going to be in the slope-intercept form, in the form of y equals mx plus b. Step number 2, then you're going to graph both equations on the same coordinate plane. Step number 3, you're going to find the point of intersection when you graph those two, when you put together those two graphs. And then once you find that point of intersection, that is your ordered pair that makes the solution true. So then what you would do is you would check the coordinate algebraically by substituting that intersecting point into each equation to see if it's true or not. So those are the steps. Write the equation in the slope-intercept form. Graph them, find the point of intersection, and that point of intersection is going to be your answer. And then you got to check it by substituting that into the original equation. So let's just get started with some examples here. We have example number 1. They want us to solve the linear system graphically, then check the solution algebraically. So we have here 3x plus y equals 11. And x minus 2y equals 6. I'm going to put these, step number 1, we're going to put them into the y equals mx plus b form. So for the first one, 3x plus y equals 11. I'm going to subtract the 3x to both sides. So what I have is y equals negative 3x plus 11. Then I'll solve the next one here. We have x minus 2y equals 6. I will subtract x to both sides. So I have negative 2y equals, I'll write it in the mx plus b form, which is negative x plus 6. We'll divide negative 2, divide negative 2 to both sides. Let me write it over here. We're running out of space. Negative 2y equals negative x plus 6. Divide negative 2 to each situation. So what I have is y equals negative x over negative 2 is going to give me a positive 1/2 x. Positive 6 divided by negative 2 is going to give me negative 3. So when I rewrite both of these in the y equals mx plus b form, we have y equals negative 3x plus 11 and y equals half x minus 3. So let's graph both of these. First, for the first one, we'll start at positive 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Since I'm cutting it close on the graph here with going off the graph, what I'm going to do here, we'll go down 3 to the right 1. 1, 2, 3 to the right 1, and I'm just going to keep going down. 1, 2, 3 to the right 1. So, and I can keep graphing. It might be helpful too to graph a few points here. 1, 2, 3 over 1. I'll draw my straight line. Okay, now let's graph the next point here. I'll graph that in blue. So we're going to start at negative 3. Okay, we're starting there. And then my slope here is 1/2. So we would go up 1 over 2. Now you want to intersect the two lines. So I'm going to keep going up 1 over 2, up 1 over 2, up 1 over 2. Notice that it intersects right at that point right there where the blue and red line meet up. That's where they intersect. So what we need to do there for this is we need to now determine what is my intersecting point. So I've done step number 2 where I've graphed both I have graphed both. Now I need to do step number 3. I'm going to write it over here. Step number 3 is where they intersect. They intersect at point, my x value is 1, 2, 3, 4 at positive 4, comma, we go down 1 at negative 1. So that's where they intersect at. That's step number 3. Then my last step, step number 4, I'm going to write it all the way up here because I am running out of space. What I do is I put that 4 comma negative 1 back into the original equations to make sure it equals 11 and 6. So what I would have here is 3 times, remember 4 is my x, negative 1 is my y. So 3 times x, x is 4, plus my y, plus negative 1, does that give me 11? Well, 12 minus 1, does that give me 11? It does. That checks itself out. Now I'll solve for the bottom equation here. We have x, that's going to be 4. So 4 minus 2 times my y is negative 1. Does that give me 6? So that's going to be 4 plus 2 because negative 2 times negative 1 is positive 2. 4 adding 2 is 6. That checks out. So we would say yes, 4 comma negative 1 is a solution. So notice there are a lot of steps involved there. I ran out of space as I was writing this down, but you do need to write down each step. Step number 1, putting it in y equals mx plus b. Step number 2 is graphing it. Step number 3 is writing the intersecting point. And then step number 4 is checking it algebraically, checking to make sure it's a solution. Example number 2, this one's a little bit, this one you don't necessarily have to graph. It's saying decide whether the ordered pair, so here they're giving you the intersecting point. The ordered pair is 5, 2. Determine if that is a solution of the system of linear equations of these two equations. So what we're doing is we're just substituting 5 in for x, 2 in for y into each equation to see if it's true. So I'll solve the first one. It's 3 times 5. Minus 2 times 2, does that give me 11? Well, 15 minus 4, sorry, my pen keeps drawing that line there. I don't know why it does that. 15 minus 4 gives me 11. That checks itself out. We'll solve now plugging in for the bottom equation. So negative x, that would be a negative 5 plus 6 times my y is 2. Does that equal 7? Well, negative 5 plus 12, that does equal 7. And that checks itself out as well. So we would say, yes, 5, 2 is a solution. Now, if you were to plug in the ordered pair into either one of these and it was not a solution, then that doesn't work. You would say, no, that's not a solution if the ordered pair does not equal the value for the equation there. Last example here, it says use the graph to solve the linear system. And so here they've graphed it, they've given us the equation, so we need to see where those two lines intersect. And they intersect, notice my graph is counting by 2s, not by 1s, so it's intersecting at point -2, -2. So then what we do is we need to check to make sure that is a true situation for these equations. So we'll plug in -2 for x, -2 in for y to see if it equals -2 and -6. So 2 times -2 minus y is a -2. So what we have here is -4 plus 2. Does -4 plus 2 give me -2? It does. That checks itself out. Next one, 4 times x, 4 times -2, minus my y, minus -2. Does that give me -6? Well, we have -8 plus 2. Does that equal -6? It does. So we would say, yes, -2, -2 is a solution. And that would be my answer. That is it for the section, and we'll continue with examples with the bookwork in class.